Assalamu alaikum students. Today we will solve the descriptive questions of chapter 2 exercise, that is atomic structure. Question number 1, explain the structure of hydrogen atom. Answer: hydrogen atom is the simplest atom. It consists of tiny nucleus containing one proton. Electrons are revolving around the nucleus in circular orbits of fixed energy. In ground state, that is the most stable state, electron occupies the first energy level, that is n is equal to 1. As long as electron remain in particular orbit, it does not radiate or absorb energy. The energy is emitted or absorbed only when an electron jumps from one orbit to another. Hydrogen has three isotopes, and we know that isotopes of the elements which have same atomic number but different atomic mass. So from these, protium has atomic number 1 and mass number is also 1. Deuterium has atomic number 1 and mass number 2. Tritium is the third isotope. Tritium has atomic number 1 and mass number 3. And here you can see the atom, that is. Question number 2, how how does theory of atomic structure explain ionization of atom by radioactive isotopes? So according to modern theory of atomic structure, atoms consist of positively charged nucleus that contain proton and neutron and surrounded by negative charged electrons arranged in different energy levels or shells. When radioactive isotope emits alpha, beta, or gamma radiation, these radiations carry enough energy to interact with the atoms in nearby matter, and these radiations can pass through the matter. The energetic radiations collide with the atom. If radiation transfer more energy than an electron's binding energy is energy that keeps the electron bind with the nucleus of the atom. One or more electrons are knocked out of them. The atom loses an electron and become positively charged, that is also called cation. The removed electron may itself collide with other atom, causing further ionization. Generally, we can represent atom plus radiation, and it will result in the positive ion and electron. For example, if we have helium atom and radiation, it can lose this helium atom can lose electron when radiation will fall on this atom, and it will result in He positive, helium cation and electron. So helium atom loses one electron and become positively charged. Question number 3, what is radioactivity? So radioactivity, we can say several isotopes of the elements exist where nuclei are unstable. They emit excess energy in the form of radiation. This process of emission of radiation is called radioactivity, and isotopes which emit radiations are called radioactive isotopes. For example, tritium 1H3. Tritium has atomic number 1 and mass number 3, and uranium, which has atomic number 92 and mass number is 238. These are the radioactive isotopes. Next part of this question is explain any three applications of the radioactive isotopes. Number 1 application is the medical imaging. So radioactive isotopes are useful in medical imaging. Medical imaging means to take image. Doctors use them to diagnose the disease by injecting patient with small amount of radioactive fluid. For example, technetium-99m is used for diagnostic imaging across human organs like brain, lungs. Doctors use special camera to watch how the radioactive fluid moves. Second application is the radioactive dating. Radioactive dating is method for finding out the age of an historical object containing organic material. So only material containing organic compounds can be detected by using the radioactive dating with the help of radioactive isotope of carbon-14. The method involves measuring the proportion of carbon-14 in the sample from dead plant or animal like piece of wood or bone, which provide information that can be used to calculate when the animal and plant died. The older the sample, the less protein will be detected. Third application is in agriculture and food preservation. Radioactive isotopes are used to improve crop yield and preserve food. For example, cobalt 60 is used to irradiate food, killing bacteria and extending shelf life. They are used in mutation breeding to develop improved varieties of crops with better resistance and high yield. Question number 4. Find the relative atomic mass of mercury from the given data. So according to book method that is used in your textbook, relative atomic mass of mercury can be calculated by using the isotope mass and relative abundance. So we will keep one isotope mass and multiply it by its relative abundance plus atomic mass of the second isotope multiplied the relative abundance of the second isotope plus atomic mass of the third isotope multiplied by relative abundance, and so on. Mass and relative abundance of all the isotopes will be multiplied, and after their summation, and we will divide this by 100, and the answer in case of mercury will be 199.39.